Hi, I'm Subir. Welcome to 1000 Real Enterprise DevOps question series that would help you to prepare for interviews. We know interviews are unpredictable, but the truth is the same questions keep showing up. I have been on both sides of the interview table, and these are the ones that matter most. Before we go to the question, we should keep in mind that real interview questions are rarely straightforward, especially nowadays. They are always scenario based, that is designed to test how you think, how you communicate, and troubleshoot in enterprise production environments. This is the first video in our 1000 DevOps CI/CD interview series, where we will tackle real questions on Linux, then Kubernetes, Docker, Prometheus, Grafana, and other technologies as well. I will break the questions down step by step so you understand not just the answers but the reasoning behind them. The goal here is to help you explain and troubleshoot with clarity, confidence, and credibility. The exact qualities interview panel at multiple MNCs, that is like global MNCs and FANG companies, look for. Stick around, and if this helps, considering subscribing so you don't miss the next one. Here's the question. You are on call and receive alerts about high CPU usage in compute cluster. How would you investigate and resolve the issue? It's an important question, and here's why it really matters. This question tests systematic thinking. That is like how clearly you can move from a big picture system visibility down to fine details of processes and logs. It will reveal whether you are fluent with right commands under pressure, and whether you can judge when to dig deeper or take right action. In short, it mirrors the kind of real incidents engineers face every day. Before answering, remember that we have some incorrect approaches, and we must avoid that. We must avoid rushing to kill processes without verifying logs. Then we should not neglect cluster-wide visibility by focusing only on one node, and we should not overlook process arguments that could reveal rogue scripts and failing to terminate a process gracefully, since each of these mistakes risk missing the true culprit or causing data corruption in a CI/CD pipeline. So never use this approach in any interview. Also, that's a big no while dealing with issues in production too. Now let's see how to answer the questions systematically. At first, you need to confirm the scope of the problem and then identify the culprit processes. Next, you will investigate the context. Then finally, you will decide whether to terminate or remediate the process. We will discuss all these points in detail. So let me explain these points. Confirm the scope of the problem means you don't jump straight into killing or fixing a process until you measured how wide and serious the issue really is. It's like you are checking the situational awareness. This point covers system impact, where you check if the problem is isolated to one node, container, or VM, or is it affecting the entire cluster. For example, check a CPU load average, memory pressure, or disk I/O across the system. In service impact, it is to check if the process failure degrading a single microservice, or is it cascading into user-facing downtime. For that, look at monitoring dashboard, alerts, and synthetic checks. For a scope of users, is to find how if only internal test users affected, or is it hitting production customers. Duration and frequency means we check if it's a one-off spike or recurring pattern that helps decide urgency and remediation strategy. Dependencies is to find if the culprit process have downstream services relying on it. If yes, the blast radius is large. So in short, confirm the scope means quantifying the blast radius before you dive into process level investigation. It's the difference between saying this pod is misbehaving versus this pod is causing a production outage across 3 regions. Next one is identifying the culprit process. Identifying the culprit process means once you confirm that the system really is under stress, you drill down to find which exact process or workload is consuming the CPU. It's like the detective step where you're moving from the cluster is hot to this specific process or container is the one causing it. Here's how the typical step looks like. For node level check, we use kubectl top nodes or top-h top on the host to see which node is overloaded. Then next is pod level check, where we use kubectl top pods or Docker stats to see which pod or container is consuming the most CPU. For process level check, we use a ps command with a flag EO. Then the filter would be a PID, then parent process ID, then the command and percentage CPU. Then we will sort the output in terms of percentage CPU, or we can use HTOP to pinpoint the exact process. Cross-check monitoring means to validate with Grafana Prometheus dashboard to ensure the same culprit shows up in metrics. In node level checks, a kubectl top node or top or htop command. In node level checks, kubectl top nodes shows CPU and memory usage across all nodes in the cluster. It helps identify which node is overloaded. For example, if one node shows 95% CPU while others are at 40%, you know the imbalance is node specific. Alternatively, you can run a top or htop on the host machine. It will show pre-core utilization, load averages, and system processes. You can find a cluster-wide hot spots, uneven workload distributions, and you can find whether the issue is systematic or load localized. For pod level check, you run a kubectl top pod. A kubectl top pods shows a CPU and memory usage per pod. It pinpoints which pod or container is consuming the most resources. Alternatively, you can use Docker stats for container level metrics if you are outside Kubernetes. You can find rogue pods consuming excessive CPU memory, misconfigured resource request or limits, and pods causing node saturation. For process level check, ps-eo, then PID, PPID, CMD, percentage CPU. Then we sort according to CPU percentage or HTOP. For a process level check, we run a ps-eo and then filter with PID, parent process ID, command, percentage CPU. Then this will be sorted according to a percentage CPU. This will list processes sorted by CPU usage. And we can run HTOP as well. This is interactive view with CPU memory, load averages, and pre-process states. This shows the exact process consuming CPU, including command arguments. We can use it to detect whether the culprit is a containerized workload or a system daemon. Example, a kubelet logging agent. Using this, you can find rogue scripts, example Python loops, stuck CI/CD jobs, non-containerized processes, hogging resources. For cross-check monitoring, we can check Prometheus or Grafana dashboard. It will show historical and real-time metrics across nodes, pods, and services. Using that, we can validate whether the same culprit process shows up in monitoring. This will prevent false positive from transits and spikes. Using this, we can find trends that is recurring or one-off spikes. This can be correlated with alerts and synthetic checks and service level impact. That could be user-facing downtime or internal test failures. So how these steps fit together. We start broad with node level visibility, then we narrow down to pod level offenders, then we drill into process level details to name the culprit. Then we validate with monitoring dashboard to confirm scope, duration, and impact as well. So this layered approach ensures that we don't just see high CPU, we identify which exact process is responsible, whether it is affecting production user, and how urgent remediation is. Here the goal is to name the offender. Example, pod X running a Python script is consuming 95% CPU on node Y. Without this step, we would be guessing for remediation. So in short, identify the culprit process is equal to find the precise process container responsible for the CPU saturation. We don't not just knowing that the system is busy. The next thing would be investigating the context. So investigating the context is about gathering evidence before you act. Instead of blindly killing the process, you build a picture of what it is supposed to be doing, whether it's stuck, and whether remediation should be termination, restart, or scaling. So in process arguments, we use command like psef or psaux to see how the process has started. This will tell us if it's running a legitimate workload, example CI/CD jobs, or something suspicious like a rogue or script. Then application log. Here we look at container logs. We can run a kubectl log of the pod, or system logs that could be journalctl, or the logs in the node, Linux node, to see what the process is doing. This will help us to spot errors, infinite loops, or any misconfiguration. In deployment context, we try to correlate with recent changes, like was there a new deployment pipeline run or config update that trigger this issue or this error. In resource limit, we check if the process is simply under provision. Example, CPU limit is too low, rather than misbehaving. Finally, we would decide whether to terminate or remediate the process. It's about decision making, okay, after you have gathered all the evidence. It's about choosing the safest and most effective way to restore system stability. Here is what that means. In terminate the process, it's about checking if process is clearly rogue. Example, runway script, infinite loop, malicious jobs, and if it possesses immediate risk. If it possesses immediate risk, then you kill it using kill-9. Then you need to get the process ID, or you can run kubectl delete pods if the process is related to Kubernetes. It's the fastest way to free resources, but that can cause side effects like data loss if a process was mid-transaction. To remediate the process, we need to try corrective actions instead of outright termination. If the process is legitimate but misbehaving, you try corrective actions instead of outright termination. For example, restart the pod or service. You can use kubectl rollout restart if it's Kubernetes. Then you can adjust CPU memory limit or auto scaling policies. Then you can fix a misconfiguration, that is wrong arguments, bad deployment, or you can pause or reschedule a CI/CD job rather than killing it. Next would be balance urgency versus safety. The choice depends on blast radius and business impact. If the production is down, termination may be justified. If it's a critical pipeline, then remediation is safer to avoid corruption. So in short, this step is where you act on your investigation, either cut off the offending process immediately or apply a fix that stabilizes it without disruption. Here, interviewer care more about your structured reasoning than memorized commands. So a crisp scenario-based answer is must, as it shows that you can think under pressure. Considering all this, the answer should contain the details as we discussed till now. Now let's see how I would answer this question. I have mentioned the answers here, and apart from that, I will pin the sample answer in the comment section. You can check the comment section for reference. So the answer should be, if I'm on call and see alert about high CPU usage across a cluster, my first step is to confirm whether the issue is cluster-wide or isolated. Then I would check aggregate metrics in the monitoring system. For example, a Grafana, it could be a Grafana dashboard or kubectl top nodes to validate CPU saturation. Once I know it's real, I will drill down to specific node and process. I will use tools like top or htop or kubectl top pods to help identify which process or container is consuming CPU. Next, I would investigate a context. I would look at the process argument, that is ps-ef, and I will check logs as well, kubectl logs for the pod or system logs, and correlate with recent deployments or CI/CD activity. This will tell me whether it's a legitimate workload or something rogue like runway Python script. Finally, I would decide on remediation. If it's a stuck pipeline or misbehaving job, I might restart or kill the process. If it's a legitimate workload but under provisioned, I would scale resources or adjust limits. The point is to balance immediate stability and long-term fixes. So this is how I would answer the question. So once again, I would pin the sample answer in the comment. You can refer from there. And the next question will be on crash loop back off. So don't forget to subscribe, like and comment if you find the video useful.